In this third module, components and hydraulic circuit design. Here, the components and hydraulic circuit design, very important concept is components. Before designing anything, we need the components, and we have to understand the components, the structure, and then how they will behave, and then how they are going to function in the specified hydraulic circuit. So that before going to the hydraulic circuit design, we'll discuss about this components. Classification of control valves. As you all know that control valves are very important, especially the valves for any hydraulic system or pneumatic system. Valves are very important, so that we can control, we can change the direction, we can control the pressure, we can control the direction, and then we can differentially we can change the pressure to the different circuits by using different valves. So that the classification of control valves and then direction control valves, symbolic representation of the direction control valve as well as the control valves, and construction features of poppet valves, sliding spool valves, rotary type valves, solenoid valves, pilot operated direction control valves. All these are the valves, but constructionally they are different each other. But only the thing is direction control valve. Here the one thing you must be very clear. Direction of the any one hydraulic means the liquid, any one the hydraulic system can be changed. Direction of the, here particularly in the hydraulic system, the example is the oil. Direction of the oil can be changed, means the some cases the one direction the oil is moving by apply the moving, and then it is applying the pressure on the any one element. If you want to change the direction, then the direction control valves will be used. The direction will be exactly opposite to that direction. The flow of oil takes place. And then shuttle valves. Here the direction control is done by means of a one type of shuttle which is incorporated in the valve. And then check valves. Here the only one side of the flow is allowed, and the other side is not allowed. Pressure control valves. In this pressure control valves, as a name itself signifies, pressure is controlled in this control valves. Different types of valves also available in the pressure control valves, like the direction control valves as we are discussed. In this, the types of pressure control valves and direct operated type valves and pilot operated type valves. Flow control valves. In that, as the direction control valves, pressure control valves, the flow control valves also one of the type of valves. These are used for the circuit design. These are very much essential for the circuit design, because the hydraulic circuit means the enormous quantity of power will be transferred from the oil. That power should be handled very cautiously, and then very well we have to handle that pressure. Pressure is nothing but the energy. Energy is should be handled very systematic manner. Otherwise, there is no use for that the hydraulic system. Here, the flow control valves in this compensated, non-compensated compensated flow control valves. Here one of the type is needle valve and temperature compensated. See, temperature compensated. Some cases in any one of the maybe the fields of like the pharmaceutical industries and then textile industries and different industries. There is a hot fluids are flowing, so that at the time in the hydraulic circuit the hot fluid is moving. At the time the hot fluid will be having some temperature. That temperature should be handled very well. To handle that temperature, we are all using this temperature compensated flow control valves. The pressure compensated, pressure temperature compensated combination, only pressure compensated and pressure and temperature compensated flow control valve and symbolic representation will be there. And the second part in this third module is the hydraulic circuit design. After knowing all the components like this, the different types of valves and then pipings and then different things, we will come to this the hydraulic circuit design. In this designing of any one hydraulic circuit, then hydraulic circuit is nothing but the various hydraulic components manually interconnected by the pipes, and the hydraulic system of surface grinding machine is, if you take the example, to move that the grinding wheel and then surface grinding moving that table, all those things will be done by this the hydraulic system. The design of hydraulic system starts from the mode of energy transfer in the system. The energy transfer in the system is done by the pump, which allows the oil from the reservoir and transfers the same to the system. We know that the energy transfer occurs due to the changes in the potential energy inside the reservoir. As the oil starts moving outwards, there are further losses. This has been graphically illustrated in the hydraulic circuit. The hydraulic circuit design, the control of single and double acting hydraulic cylinder. Some cases there may be single the hydraulic cylinder. Cylinder is a very important part in the hydraulic system design. Second one is the double acting hydraulic cylinder and regenerative circuit. Regenerative means the whatever the same this oil pressure is there, the same pressure is again used for the other purpose. And pump unloading circuit, double pump hydraulic system, counterbalance valve application, hydraulic cylinder sequencing circuit, and cylinder synchronizing circuit. Here the single acting hydraulic circuit, here only one simple work. If there is a simple work is there, you don't want to edit the further work. There at the time the single acting the hydraulic cylinder is used. Only the thing is it will unload or load. After loading anything, the oil it has to come down to the reservoir. After unloading anything, the oil, whatever the oil is there in that single acting circuit, that should be come down to the reservoir or the tank, oil tank. There in the double acting, some cases the unloading and unloading. So the one side it is a loading takes place, another side unloading. There the one side the cylinder is attached to the loading. There the pressure is applied on the piston, and the other side the piston is pushing back to the oil, so that the unloading takes place. Regenerative circuit. Regeneration, as you all know that the name itself signifies regeneration. Whatever the oil which is carrying the energy, that same energy is regenerated in the circuit, so that regeneration of the hydraulic energy which is incorporated in the oil may be utilized for the other purpose. Pump unloading circuit. As I discussed in the first case, the single hydraulic cylinder, same thing, pump unloading circuit, double pump hydraulic system. Some cases, if the pressure requires the lot of pressure is required, then the one pump is not sufficient for the hydraulic pressure, so that some cases more than one pump is used. Here double pump hydraulic circuit design also possible and available. Counterbalance valve application. In the cranes and all those things, after lifting something, the counterbalancing should be there. How they are making counterbalancing? they don't know how much weight they are lifting, and then how it is mm, how much should be the counterbalance. At the time, what they are doing is the whatever the weight which is lifting by the hydraulic crane, the same quantity, same weight of the hydraulic oil will be counterbalanced in the other end. That the metered quantity of oil is supplied to the other end, so that the counterbalancing takes place. Hydraulic system sequencing circuit, in that circuit, the hydraulic cylinder sequencing, I'm sorry, where the sequencing is required. Wherever the timing, some cases the different components should be worked in the different time. There the sequencing is required. One hydraulic cylinder is working in the one time, and another is working in the another time. Suppose for this, if you take the example of this, the CNC machines, CNC hydraulic machines, there the if you want to machining the any one workpiece, there the CNC machines, computer numerical control machines, one by one operation sequentially the takes place. How this the operation sequentially takes place? Just nothing but the one surface finishing operation, and then another one cutting operation. Like that, sequential operation takes place. Sequential operation is by means of different timing, and sequentially it is takes place. Cylinder synchronizing circuit. Cylinder may be synchronized. Cylinder may be synchronized. Cylinder may be synchronized by taking the different the designs one by one. The simultaneously some of the cylinders should be worked synchronously. If the one cylinder is switched off, another should also switch it off. Otherwise, the both should be worked simultaneously, so that at that time synchronizing is essential. The different components in detail we can discuss here. One of the most important consideration in any fluid power system is the control, because without control we can't achieve anything. If we control something in the fluid power system, then only that controlled energy may be utilized for the other components. Otherwise, the work will not be fulfilled. The aim will not be fulfilled. So that what we have to do, it has to be controlled in the systematic manner. Then only the required work can be achieved. If the control components are not properly selected, the selection of the components also very important, because according to capacity, according to the work nature, according to the specification, we have to select that components. The entire system will not function as required. Otherwise, the function of the system will be failed. If the function of the system is failed, then whatever our goal will be failed. So that what we have to do, we have to select the component properly, and then we have to select the component according to the design. First, we have to design how much pressure is acting in the line, and what is the desired work we have to do. For that work, what type of components we have to select. What type of components means what type of valves, what type of pipings, and then how it is working, whether it is the fulfilling our need or not. We have to think all those things. Then only we have to select that components. Fluid power is controlled primarily through the use of control valves. These are the most essential the components, very essential components of this fluid power system. That is the valves. There are three types of valve, as we all discussed in the syllabus of the third module. Direction control valves. In this direction control valves, again there are in the direction control valves. See, in the direction control valves there are lot of types. Direction shuttle valve, check valve. You see here, shuttle valve, check valve, direction control valves, shuttle valve, check valve, and sliding spool valve, rotary type valves, solenoid valves, the pilot operated valves. In that, the shuttle valve, check valves, like that different. The pressure control, in this pressure control valves also, there are the lot of types. Direct operated types or pilot operated type. Direct operated type, pilot operated type. Two types of valves are there. And then first, we should know this how the walls are symbolic representation will be there. That why this symbolic representation is used. If the any one hydraulic system, hydraulic circuit design, if they the graphically, if they write in the different manner, to understand that hydraulic circuit requires lot of the knowledge, and also the some of the expert peoples are required. Otherwise, if the hydraulic components are specifically the represented by its own symbol, then the all peoples, those who are knowing the hydraulic system, they can identify what type of valve is incorporated or the adopted in the circuit. So that the symbolic representation understanding of the hydraulic the components are very essential while designing the hydraulic circuit. For that, the symbolic representation here, the direction control valves, this envelope or the square, each individual switching portion is shown in square. The each component of the switching portion is denoted by like this. The symbol for the hydraulic valve is the square black, representing the valve body, valve envelope, lines and arrows with the square indicates the direction of the flow between the opening, and these openings are called as ports providing the on the body. The small perpendicular lines, the opening or the ports of the in the walls, change in the flow direction is achieved by different positions of the valving element housed inside the valve body. These are called as the valve bodies. These arrow marks, as I said, flow path is indicated by means of the arrow within the square. Within the square, this arrow, the flow is from the bottom to the top takes place. The second, third one is closed position. Within this body, the square envelope, this envelope is called as the valve body. Valve body, within this symbol is closed position. Here, look at here. There are two square blocks or the square envelope. One B and A. Two position. The same valve, same envelope will be there, but the position of the valve is two, B and A. Here three envelopes or the three squares are incorporated in this valve. B, O, A. Here the three position will be there. Valve. One is the open, close, close, or open, close, like this. Three position of the valve will be there in this the valve. Before going to this, some of the ports, then what it signifies? Ports, just openings or the pipes are incorporated on the surface of this square or the envelope are called as a ports, through which the oil may be entering into this valve position. See, A and P. P is from the power pack. Power pack means from the cylinder and pump will be there. From there, the pump is sucking the oil from the reservoir or the power pack, and then it is from the power pack it is applied to the envelope. Here it is going back to the tank. And A and B are the specified the lines of for the different hydraulic circuit. B and A, two ports are added to two position valves. Two position valves, these are the two positions, but two ports are there, 1 and 2. these are ports are not connected. These ports A and P. Here you can see the two flow paths. Two flow paths. These are the one flow and another flow. The P to A is the one flow, B to T is the another flow. Maybe interconnection also possible. See here, interconnection also possible. P to B to B to P also it is possible. A to T also possible. Okay, like this, the two flow paths, two ports, and then two position, two ports, and two flow path. The valve, this one is. See, once again, I'll tell you this. This is a very important for the hydraulic circuit design. See, two position, two envelopes, two blocks are there, and then two ports. Ports are extended surfaces from this envelope, extended lines. Means these are the connecting lines, and then the paths are these lines. These are the flow paths. Like two position, two flow path, two ports, and then two ports are connected, two ports are closed. These two ports are connected, these ports are closed. These are closed, so it's connected. See here, two-way valve, two ports, two positions, two-way, 2x2-way valve, two position, two ports. Normally, closed position P is not connected to A. P is not connected to A. When the valve is not actuated, the valve is closed. Right? Valve is closed.